Okay, I'm gonna go through this review. I'm gonna work through every single problem, tell you every single step that I make when I'm solving these. That may be overkill for some of you, but I want to make sure that everyone understands how to do these because our test is going to be on Friday.
Oh, can I put my right one?
No. On the first page, these logarithms are just asking the question that we talked about when we first started logarithms. So on number 1, log base 4 of 64 is asking 4 to what power equals 64. So in your calculator, you try different exponents on 4 until you get 64. You should get your answer to be 3. Number 2, log base 3 of 1 over 243 is asking 3 to what power equals 1 over 243. When you raise a whole number to an exponent and you end up with a fraction, that means your exponent will have to be negative. So when you're trying this in your calculator, I always start with -2. And when I'm trying positive exponents, I start with 2 and go up. So 3 to the -2 power, it's going to give you a decimal. If you press math, enter, enter, it gives you that decimal as a fraction. But this isn't what we need. So we move on to 3 to the -3rd power. Math, enter, enter. That's not it. 3 to the -4th. Math, enter, enter. That's not it. 3 to the -5. Math, enter, enter. That gets us the fraction we were looking for. So our exponent, our answer is -5. On the test, I don't have to see this step in your work. If you just write your answer, that's fine with me on the first page. Number 3, log base 10 of 10,000. 10 to what power equals 10,000? Your answer should be 4. Number 4, log base 2 of 32. That's asking 2 to what power equals 32? Your answer is 5. Number 5, log base 3 of 1 over 81. 3 to what power equals 1 over 81? So again, our exponent will need to be negative. It should be -4. Number 6, log base 8 of 2 is asking 8 to what power equals 2? So on this one, we have a whole number, we're raising it to a power, and we end up with a smaller whole number. This means your exponent will be a fraction. So when you're trying fractions, start with 1/2, go to 1/3, 1/4, 1/5, and so on. So 8 to the 1/2, which I'm just entering that as 1 divided by 2, because it is a simple fraction. We can do it that way. But that's not it. So we try 8 to the 1/3. That gets it. So our exponent, our answer is 1/3. Questions on the first page? Yes. Yes. So the other way that you could be doing these is like for the first one, if you set that equal to x and then change this to exponential form to say 4 to the x power equals 64, and then solve for x or find x by trial and error, that's fine too. Yep. Any other questions on this page? All right. The next section, we're just converting between exponential and logarithmic form. We don't have to solve anything in this section. On number 7, we're starting in exponential form, so we need to change this to log form. We can use the loop trick by starting at the base, which is 9, draw a counterclockwise loop around to x. And since we are changing this to log form, the very first thing you have to write is log. And then you can follow your loop. So log base 9 of y equals x. On number 8, it's already in log form, so we want to change this to exponential form. Use the loop trick by starting at the base, which is x. Draw a counterclockwise loop around to y. And we're changing this out of log form, so we don't write log, we just follow our loop. X to the z power equals y. Okay, number 9, log base b of 123 equals a. Number 10, 2 to the u power equals v. Number 11, log base x of 2 equals 3. And number 12, 2 to the w power equals m. Questions on that section? Okay, last section, our instructions say, use the properties of logarithms to solve the following equations. Show all of your work. Check your answers only if you find more than one value for the given variable. So be sure to show all of your work on this section. That's going to be very important to get you any sort of partial credit. And there's also things that if I feel like you haven't shown enough work to prove to me you know what you're doing, then you may get counted off a point or two. So just write down everything that's in your brain, basically. And then you don't have to check your answers unless you end up with more than one value for x, which on the review should only happen on number 16. So that's just saving you a little bit of time there. Okay, number 13, log base 4 of 5x plus 1 equals 2. So we have a logarithm on one side with just a number on the other side. This means we have to change to exponential form. So start at 4, draw a counterclockwise loop. You should get 4 squared equals 5x plus 1. From this point, we just need to solve for x. So getting x by itself, we subtract 1 from both sides. Be careful here. A common mistake that I've seen is students will say 4 squared minus 1 is 3 squared. That's not true. Okay, 4 squared is actually 16, and 16 minus 1 is 15. So we get 15 equals 5x. If this is an issue for you and you've made this mistake a lot, I would suggest from this step, go ahead and add another step in there to change 4 squared to 16 before you start solving for x. Okay, if you can remember to do it correctly without adding this extra step, that's fine too. Okay, from here, to get x by itself, we need to divide both sides by 5. So we end up with x equals 3.
No, I haven't. Like at all. I still got 3.
What did you do?
I have no clue. But I got 3. I did 4 to the 7.
Okay, so since we only got one answer for x, we don't have to spend the time to check this. If you want to check it, if you have extra time on the test and you want to check and make sure you got the right answer, that's fine, but you don't have to. Number 14, we have a logarithm equal to another logarithm. Because they have the same base, we can set 3x minus 1 equal to 2x plus 3. So 3x minus 1 equals 2x plus 3. You can only do that because there's a logarithm on both sides. Now we solve for x. We want to get all the x terms on one side while getting everything else on the other. So I'm going to subtract 2x from both sides. That doesn't necessarily mean that you have to take that first step. There's a bunch of different ways that you can solve here. When I do that, my x terms over here cancel out, which means I'm left with my x term being on the left side of the equal sign. So I'm going to end up wanting to get rid of this -1. So I'm going to go ahead and add 1 to both sides in the same step. So that gets rid of that. 3x minus 2x is just x. 3 plus 1 is 4. X equals 4 is my answer. Did anybody start by subtracting 3x from both sides? Okay, that's fine if you did. You would end up with a negative x that then eventually you would either want to multiply by -1 on both sides or move that to the other side. I think it would just create more steps for you if you did it that way, but it can be done, just to let you know. Why did I do that? I compared my x terms first, and I compared my x terms first, and since 2x is smaller than 3x, I knew I would want to move this over here. So to do that, I subtracted 2x from both sides. And then I knew that that was going to put my x terms on this side, and I would want everything else to the other side. So I added this 1 to both sides to get rid of this -1. Pretty much. Okay, again, we don't have to check on this one because we only got one answer for x. Next page. Number 15, we have a logarithm on one side with just a number on the other side. So we change to exponential form. 27 to the 1/3 power equals x plus 4. Okay, 27 to the 1/3 power is not like a common thing for people to know. So on number 13, when I skipped straight to just subtracting 1 from both sides, that was pretty simple for me to do. On this one, I'm going to go ahead and add that extra step of getting the value of this first. 27 to the 1/3 power is 3. Now to solve for x, we subtract 4 from both sides. We get -1 equals x. When you write your answer, we like to see it as x equals a number instead of a number equals x. If you were to leave this as your answer, that's fine. I wouldn't count off, but I can't leave that as my answer. It's wrong. It feels wrong. I mean, I won't count off though. Okay, so again, we get one answer for x. We don't have to check this one. Number 16. On number 16, we have 2 logarithms being added together. So we want to combine those logarithms into one. When we do that, log base 2 stays the same. And then we multiply x times x minus 6. Because the logarithms are being added, that means we multiply x times x minus 6. Now, several people have made the mistake of leaving this logarithm off and just writing x times x minus 6 equals 4. That is incorrect. You can't leave the logarithm off on this side because there's not one on this side to match. You have to leave the logarithm. Because now we have a logarithm on one side with just a number on the other, which means we change to exponential form. So we get 2 to the 4th equals x times x minus 6. Okay, 2 to the 4th is 16. We can distribute the x here to get x squared minus 6x. Because we have an x squared term and a term that has just x, we're going to have to factor. So to factor, you have to have everything on one side of the equal sign set equal to 0. So we need to subtract 16 from both sides. So we get 0 equals x squared minus 6x minus 16. To factor, we have 2 sets of parentheses. We know that x goes in the front of both of them. And then we want to look for two numbers that multiply to be negative 16 and add to be negative 6. So if you have trouble with that, we're going to look at factors of negative 16. Okay, factors of 16 would be 4 and 4, 2 and 8, 1 and 16. And then let's see which combination of these numbers add to give us negative 6. So 4 and 4, one of them would have to be negative to multiply to get negative 16. So then when we add them, that would give us 0. That's not going to work. 2 and 8, one of them has to be negative. Looks like if I make the 8 negative, 2 times negative 8 will give me the negative 16 I need. And then 2 plus negative 8 will give me the negative 6 that I need. These are my factors. So we get x plus 2, x minus 8.
Does it matter like if we put the A or the B?
It does not matter as long as you have the signs correct. So I could have put x minus 8, x plus 2. It doesn't matter what order. Right. Now, from here, I tried to show you guys a shortcut, but it's causing a lot of people to make mistakes. I told you could skip some steps and just say x equals negative 2 and x equals positive 8, basically switching the signs of what we have in our factors. Some people are forgetting to even do that, and you're calling positive 2 and negative 8 your answers when that's not the case. So if you can do it correctly and skip some steps, that's fine. If you can't, here is what the steps are if you want to make sure and check yourself. From this point, you need to set each one of these factors equal to 0 separately. So x plus 2 equals 0 and x minus 8 equals 0. Then we solve for x in both of these equations. So subtract 2 from both sides, and we get x equals negative 2. Add 8 to both sides, and we get x equals 8. So we did get 2 answers for x, which means we need to check to see which ones of these are solutions. Okay, so checking answers, you need to go all the way back to the very first line of the problem and plug in these values for x. So if we're checking x equals negative 2, we have log base 2 of negative 2 plus, yeah, pretty much.
Good catch, buddy.
So we have negative numbers here and here, actually. So x equals negative 2 is not a solution. I have to see at least this part of you checking negative 2 as a solution. You can't just cross out x equals negative 2 because it's negative. I have to see that you actually tried to start checking it and then noticed a negative. I get that you can just look at it and see that that's the case, but I can't see inside your brain. Will you guys wait up, please?
What? Have mercy.
Okay, so make sure that you show me somehow that you started to check negative 2 and that it didn't work before you crossed it out. I don't want to think that you just crossed it out because it was negative. Okay, let's check x equals 8. So going back to the very first line of the problem, we've got a positive 8, and then we have 8 minus 6, which is a positive 2. We don't have any negatives to worry about. So that means we can continue checking this. When we continue checking this, we can basically follow the same steps that we followed when we were solving. Now, that doesn't mean that we're going to do everything exactly like we did, but the general steps we took is the steps we'll take when we're checking. So the first step we took was to combine these two logarithms into one. So we still have log base 2. Then we have 8 times 8 minus 6, which I'm going to go ahead and just say is 2. And that's one way that we're not following exactly the same steps because we didn't know what x was when we were solving. Now we have a number there, so let's make it as simple as we can. So 8 minus 6 is 2. I just put a 2 there instead of keeping it as 8 minus 6. Okay, then we switch to exponential form. 2 to the 4th equals 8 times 2. 2 to the 4th is 16. 8 times 2 is 16, and 16 equals 16. Yay. So x equals 8 is a solution. Questions on this one? I know it's the most complicated of both of this section. All right, number 17. On number 17, we have two logarithms being subtracted. We want to combine these into one logarithm. When we do that, the base stays the same, so it still is log base 3. But then since these logarithms are being subtracted, that means we divide 126 divided by 9. And that is still equal to log base 3 of x. Okay. From this point, we have a logarithm set equal to another logarithm. They have the same base, which means we can set 126 over 9 equal to x. Then we want to solve for x. Well, x is already by itself, so we just need to get the value of 126 over 9 in our calculator. It is 14. So x equals 14 is our answer. And because we only got one value for x, we do not need to check.